desert pavements. They are natural surface covering found in arid, semi-arid regions made up of closely packed pebbles, stones and gravels with very little or no sand or fine particles. It often looks like rocky mosaic or cobbled surface stretched across the desert floor. The surface of the desert contains a minimum of fine particles like sand, silt and clay, along with larger stones. Wind through deflation removes the fine particles, and over time only heavier particles and stones are left behind, as they are too heavy to be lifted by the wind. Later, the stone settles and through compaction, they form a tightly packed surface layer. This layer prevents further erosion of the material beneath. This becomes a stable protective cap that reduces further wind erosion of the underlying soil. They are also called as reg, used in North Africa, Syrer, used in parts of Sahara, Libber, plains in Australia. Lag gravel. They refer to a coarse rock fragments such as gravel, pebble and cobbles are left behind on the desert surface after wind erosion, deflation removes the finer particles like sand, silt and clay. It's called lag deposits because it is a residue or the leftover material that is too heavy to be carried away by the wind. The desert surface initially contains a mixture of fine sand, dust and coarse like gravel, pebble material. Strong winds picks up and carries away lighter particles like fine sand, silt and clay. This leaves the heavier fragments behind because they cannot be lifted by the wind. As deflation continues over time, gravel and stone accumulates, forming a layer of lag gravel. Eventually, this gravel layer protects the surface from further deflation. It may prevent wind from reaching and eroding the finer materials beneath. There is no sorting of sizes. Lag gravel plays a crucial role forming desert pavements, shows past wind creativity and helps stabilizing the desert landscape. Stone lattice. It is a type of desert surface pattern formed when wind erosion, deflation removes fine particles, leaving behind a network or a grid-like arrangement of stones, pebbles or rock fragments. This pattern resembles a lattice or a mesh spread across the ground. The desert, composed of both fine-grained materials like sand, silt and coarse-grained particles like pebbles and stones, which are interspread with each other. Strong winds carry away lighter, finer particles, especially in interspaced between the stones. The remaining stone settles in geometric pattern, forming a natural grid or a network due to differential erosion, occasional rainfall, wind vortices shape the distribution. They appear as interconnected stone pattern, often hexagonal or polygonal, often formed in hyper-arid desert like Sahara Desert, Atacama Desert, Chile, Thar Desert, India. Dimesols. They are also called as dimesol coffees, a French word for ladies with hat or hoodoos. They are tall, slender rock pillars that have a capstone or a large rock balanced on the top. These unusual landforms are the result of differential erosion, where softer rock erodes more quickly than a harder, resistant rock layer above it, formed in areas with alternating layers of soft and hard rocks, sedimentary rocks like clay, silt and sandstone. The hard rock capstone protects a column of soft material underneath from erosion. Water erosion wears away the surrounding softer rock more rapidly. Wind erosion may also contribute, especially in the semi-arid region. A pillar-like spire of soft material remains topped by a flat rock cap. Over time, capstone falls from the pinnacle. The pillar is soon destroyed. It is mainly found in France, Haute Alps, Alpes de Haute province regions, Bairi Canyon National Park, Utah, Cappadocian region of Turkey. In India, it is found in Spiti Valley, Himachal Pradesh, Ladakh region. Demoiselles show differential erosion by wind in deserts and semi-arid mountainous regions. They are valuable for understanding sedimentary layering, erosion resistance and geomorphic evolution. Inselbergs. Word is from German word Insel meaning island and Berg meaning mountain that rises abruptly from a gently sloping or nearly level plain. Inselbergs were used by Passage in 1904 to indicate a sharply rising residual hill above a flat surface in South Africa. They are typically formed from hard resistant rock such as granite and gneiss, which survives while the surrounding softer rocks are eroded away over geological time. Hard rocks like granite resist chemical and physical weathering more than surrounding softer rocks. The surrounding rocks erode more rapidly over millions of years. Erosion strips away the weathered material, leaving behind the resistant rocks mass as inselbergs. They are more common in tectonically stable shield areas where the rocks are ancient and deeply weathered. Inselbergs are found in various climatic conditions like from humid to semi-arid regions. It is best found in savanna regions. In humid regions, they are formed as sugarloaf mountains in Brazil, also found in southern Georgia in USA, southern Africa especially in Zimbabwe, South Africa and Australian deserts. Types of inselbergs. Bunhards. They are large dome-shaped inselbergs with smooth convex surface formed mainly through chemical weathering followed by exfoliation. Example, Sugarloaf Mountains of Brazil. Tors. Inselbergs composed of started blocks or boulders usually from granite formed by deep weathering along the joints. They are common in humid tropical as well as temperate region. Castelcopies. Small knoll-like inselbergs made of granite found especially in southern Africa. Several theories were proposed on formation of inselbergs by geomorphologists like L.C. King, Twildale, Peel, Linton and many others. Pediplanation theory. It is developed by L.C. King in 1953, especially in relation to landscapes of Africa including Tanzania, Zimbabwe, South Africa, New Hampshire of USA and many others. According to the King's theory, the inselbergs are formed due to the formation of pediplain as a residual hill through lateral erosion and weathering of the scraps. Scraps are the escarpments which are steep sloped cliffs. This theory explains the presence of inselbergs on low plains. They are usually associated with the scrap, retreat and long-term denudation. But King's proposition virtually does not apply to inselbergs similar to bunhards or bluffs. Rather, it applies to medium and large scale hills. Other experiments suggest that bunhards are formed as a cliff retreat which is substantially argued. Explanation theory or deep weathering theory. Several geomorphologists envisaged the theory include Twidale, Linton and Ollier. According to it, inselberg is a result of deep chemical weathering beneath the surface followed by erosional stripping or etching of the weathered mantle. Chemical weathering affects rock to a considerable depth under the thick regolith. Hard, massive rocks like granite remains less weathered due to resistance and lack of joints. Subsequent erosion, etching by rivers, wind and runoff removes the softer weathered material. The unweathered rock mass are left standing as inselbergs. The theory implies that the rate of denudation and stripping must overtake that of steep weathering. If deep weathering is faster than the basal surface, will not be exposed to the surface, but rather it keeps lowering explanation, making more sense in explaining inselbergs such as Banhard's, Thor, but not hilly inselbergs. Exhumation theory. This theory states that inselbergs are ancient landforms that were buried under the sediments or regolith and later exhumed by erosion. Structural theory. This theory states inselbergs are structurally controlled, formed due to tectonic upliftment, faulting or jointing which influences erosion patterns.